I am Min Yue. Today, I will be presented our assignment for the subject Data Communication and Networking. Before that, let me introduce my group members, which are Kako Chen and Dajiwan. And our project title is IoT Flood Alarm and Detection System. Based on the bar chart shown in the figure, we can see that flood has the highest cases among all the natural disaster events, which are 38 cases. So, what is flood? Flood is one of the major natural disasters experienced in Malaysia. Malaysia Drainage and Irrigation Department has classified the floods into two categories, which are the flash flood and the monsoon flood. And the difference is the duration taken by the river flow to recede to the normal level. In Malaysia, majority of the citizens are living in the high-risk flood zones. However, most of the flood monitoring techniques are based on the telemetry system, which is required the transmitters and repeaters to relay the information to a central terminal. Such approach is costly and is not reliable when there is a malfunction of equipment in the certain section of the sensed area. Eventually, life, properties, and means of a livelihood are greatly undermanaged. Therefore, it is necessary to build an affordable, reliable, community-based, real-time flood alarm and detection system using the wireless sensor. The objectives of the project are as follows. First of all is to detect and monitor current water level using the ultrasonic sensor. And the second one is to develop an IoT-based data processing and transmitting unit. And the third one is to use an app to alert the citizens about the flood water level. The block diagram shown here is illustrated the scope of work for the project. The ultrasonic sensor is used to detect the water level parameter. And the second one is the push alert application, which is used to share the alert notification to the public or rescue team. The buzzers and the LEDs are used to act as an alerting system. And the ThinkSpeak server is used to monitor the data of the water level parameter. The schematic diagram is illustrated the system architecture of this project. When the water level reaches a danger level, the ultrasonic sensor will sense the signal and collect the data to the Node MCU V3. The buzzer and the LEDs will be activated. Then, the microcontroller will transmit the data to the ThinkSpeak server with the Wi-Fi or Internet connection. After that, the alert notification will be sent to the devices or applications to the user as a warning. This is the schematic diagram of the sensor detection circuit. And there are 4 types of color of LEDs are used, which are red, white, yellow, and green. For the software development, we have to register an account at the push bullet application. Then, at the access tokens part, we need to click the create access token to get the token and copy it. After that, the token will be pasted in the push bullet service in the pushing box website. The next step is to create a channel in the ThinkSpeak. The channel ID and the right API key are copied to our coding. And then, the 2 scenarios have created and the device ID for each scenario is copied into the coding. This is the coding of the project. The copy device IDs, channel ID, and the right API key from the previous website were pasted into the highlighted red box. This coding is to set up the Wi-Fi connection and also the pin function, and also to initialize the buzzer and the LEDs. In this part of the code, when the distance is less than or equal to 10 cm, there will be a warning notification is sent to the device. This line of coding will go to the void send notification function to trigger the alert notification in the pushing box. The same goes to the distance larger than 10 cm and smaller or equal to 20 cm. There will be an alert notification is sent to the device. And this line of coding will go to the void send notification to function to trigger the alert notification in the pushing box. This coding is to continue the previous part of the code. This flowchart is to illustrate how the IoT flood alarm and detection system works. These 2 pictures are showing the prototype of our project. We have used a water pill and a measuring tape to build the prototype. The table is explain the condition of the LEDs and the buzzer for each different level with respect to the measurement between the water level to ultrasonic sensor. This is the output graph of the sensor data from the thin view. The first graph is showing the distance at 32 cm, and the second one is 22.321 cm, and the third one is 12.478 cm, and the last one is 8.517 cm. These two pictures are showing the alert notification from the push bullet. The first picture is when the distance is more than 10 cm and less than or equal to 20 cm. Then the alert notification is received and saying, "Warning, water is at level 2. The second picture is when the distance is less than or equal to 10 cm. Then the warning notification is received and saying, "Warning, water is at level 3. Flood is coming. Evacuated." In conclusion, the flood alarm and detection system is designed by using the concept of IoT. When the water level is detected as moderate risk and high risk level, non-MCU V3 microcontroller will trigger the alarm by activating the buzzer and flashing the white and red LEDs to alert the public. The public who have installed the push bullet application on their devices can receive the alert notifications for every 5 seconds if the water level is still in the moderate risk level and high risk level. They also can undertake the appropriate responses to minimize the damage and losses of belongings, save the lives, and even reduce the impact of the disaster. Now let's move on and watch the demonstration video about how this prototype is works.